In the replit we're looking at now, I've got some notes ready to display the big ideas of 2.1 and 2.2 from CS Awesome. And one big difference today is you'll notice, in addition to the main.java, that we also see something called student.java. This is a class that I made ahead of time. And when you make your own class, like I've done here, this is something that we're going to use to build objects from. And objects are like our own user-defined variable types in a sense, but they're different than primitive variables that can only hold on to a certain type of value, right? A primitive int can only hold an integer, and it actually has to be within a certain range from like -2 to +2 billion. Double can hold numbers with decimal values. A Boolean can hold true or false. When I make my own class, I can set it up to hold all types of information. So I'd like you to think about your PowerSchool entry. What I mean by that is, in PowerSchool, everybody has an entry and their teachers can access it in their PowerSchool account by clicking on that student's name. When I click on your name, I can see all kinds of information. In addition to your first name, your last name, ID number, I can see all of your classes. I can see your mailing address, your parents' names, any phone numbers attached to you, previous classes you've taken, all kinds of things, Now, all of that is stored in some location in the computer's memory. And at some point in time, somebody had to set up variables to hold on to all of that information. All of those variables belong to your student account. Now, there's thousands of students within Arcadia Unified. They didn't rewrite the code and create all those variables over and over again. So it's not like somebody had to make a different first name variable for everybody and call it, first name 1, first name 2, first name 3. Nothing like that happened. What they did was they set up one blueprint for all of the things that a student could be, and they called it a student. And then every student gets created from that blueprint. So I have an example blueprint here. Now for me, I've only made a student a few things so far. I've made it a first name and a last name and an ID number. We could add all kinds of attributes to what a student is. You could have a mailing address. You could have phone numbers attached to your account. We could say, are you meeting your graduation requirements? Have you passed all of your English classes? All kinds of things. Maybe, for example, we want to put like a double here and keep track of your GPA. Okay, then every student now would have a GPA. An attribute is something that describes the object. The object in this case is a student. We're trying to digitally represent everything we know about a student. Think of like a Boolean variable we could put here. Some students have off-campus privileges. So, for example, you could make a Boolean called off-campus, and set it to true or false. And so if you read true here, then that student's ID card would probably say on it that they were allowed off-campus privileges. Most students aren't, but seniors and some other students, maybe if you're in like Apache News or something, you might be able to get an off-campus permit. Okay, so there's all kinds of things we could put here. Like I said, we could put your address, whatever. So anything that describes the object is called an attribute. Another key piece to this object is going to be what we call its constructor. Its constructor is how we will build objects from this class. So when we build an object from the class, we'd like to be able to set up all of these different variables. It's a little tricky. So sometimes there's different ways to do it. Sometimes the variables are assigned automatically and then changed later. Sometimes at the moment of creation, you want to initialize all of the variables or maybe just a few. And you might have some default values built in. Okay, but anytime you see a special method, methods always end in parentheses, that has the same name as the class, that's called a constructor. This class has several. We'll try them out in a minute. Okay. And then any type of class is also allowed to have certain behavior or methods. These are the things that it can do. So I've just put in a simple method here that can display the name of this student in a print statement. Okay, so I've got this student class set up. These are our learning goals for today. You should read through these when you get a minute. All right, we've looked over the class, we've identified its attributes. What were the attributes? Well, every student had a first name, a last name, and an ID number. And I just added a couple more attributes. I added a GPA, and I added one to decide whether or not that student had off-campus permission. Okay, so create a student object named stu1 and initialize it with the student object using the no argument constructor. Here's what that means. Okay, creating an object is kind of like declaring a variable, but we're not declaring an int or a double or a Boolean or any other type of primitive right now. So the rules are a little bit different. However, it's still similar, like we still declare a type. Okay, so when I create a student object, I'm declaring that it's a type student. I'm still giving it a name, just like a variable. I'm going to call this variable stu1. In fact, if I stopped right there, I would have simply declared that there was a stu1 reference to a student object. It's like declaring an int or a double, okay? But this variable or object doesn't hold on to just a primitive value in the sense of like a number, okay? It actually holds on to something called a memory address. And then the memory address takes you to where all of the information is that describes that object. Now we're going to go ahead and we're going to initialize it. Now, initializing user-defined objects, okay, is a lot different than initializing primitives. We can't just put a value in here. I can't just put a number, okay? I can't just put a name. So I can't just say, oh, my student's name's Fred. To create an object from the student class, you have to use the keyword new. See how it turned blue? And you have to use that keyword new in connection with a constructor from that class. Okay, a constructor is a special rule made for how to create an object from the class. My student class had several constructors. Okay, this is what we call its no arguments constructor, meaning that the parentheses here are blank. In those parentheses, or you put what you call your parameters. And in my student class, there was several different ways to do this. I could specify the name and ID number of the student, okay, at the moment that I create the object. I could just specify the name and omit the ID number, and then one would be automatically assigned. Or I could just provide none of the information, and that's what I'm doing here. This is called the no argument constructor. When you have multiple constructors like this, we say that the constructor has been overloaded. There's more than one possibility. Okay, so to use the no argument constructor, I use the keyword new in connection with the constructor. And again, this could be done over 2 lines of code. I could say student stu1 semicolon, and on the next line of code, I could say stu1 equals new student, just like we can with variables. Let's say we want to create a student object named stu1, and we want to initialize it with, I'm not really sure what's going on there. I don't think we need to do that twice. Sorry. Let's make one called stu2. All right. So student stu2, and this time we're going to initialize it using 2 string literals, your first name and your last name. So here's how this is going to look. I'm still going to say new student. However, this time I'm going to specify in the parentheses what the name of this student is. So go ahead and put your first name, your last name. Okay, I'll put mine. And now my student would actually have those attribute values associated with it. And we could even do it with an ID number. Now, the order that we do this in really is crucial. So if you look at the rule, okay, for the student constructor as laid out in the student class, it wants to see in order string first, string last, and ID. So string, string, int. Remember, a string for us right now is just characters enclosed inside of double quotes. We're going to expand on that topic a little bit more in a week. Okay, but for now, we're just thinking string literal, something in double quotes. All right, so right here, I could put, again, my name. Okay, I'll put my last name. And this time I'll put my ID number. Now, again, the order matters there. It has to actually appear. My first name followed by my last name. and then the integer, in this case, my ID number, has to come third. If you put those in an alternate order, your code wouldn't run. If you try hitting run right now, nothing's going to print, but we also shouldn't get any error messages. So if you're getting some error messages right now, you must have some little bit of a syntax error somewhere. Maybe the word new, maybe you didn't spell student correctly. Okay, all kinds of little things could go wrong. All right, it says uncomment the following line of code and run. So let's see what happens this time. And if you remember, I had put in a method into the student class that should print this student's name. And my screen actually printed my name, Brian Zerla. Your screen should print whatever name you entered in for student 3. It says reassign stu3 to null and try running the following line of code. What happens now? Okay, so what that would mean is, this is a little weird. Technically, when we created stu3, if we had just said student stu3 semicolon and just stopped, we would have been assigning what's called like the null pointer to stu3. This is a way to, you still have the variable and it's still declared, but it's not really holding on to anything now. It's not holding on to a name. It's like it hasn't been initialized with anything. So all of those attributes are empty, but even the variable itself doesn't really exist anymore. There's no object associated with it. And so if we tried to print the name of a null pointer, we'd get a strange null pointer exception. The moral of the story here is you have to initialize your variables before you can use them. Okay, so to avoid null pointer exceptions, we always want to make sure that we initialize our user-defined objects with valid constructed types from that field. Okay, so let's turn these off here so that we don't see that error message again. And finally, we're going to try to create a student object named stu4 and initialize it with the student object using your first name, your last name, your ID number, and the 2 attributes that we had. So if you noticed back in the student class, we're going to add one more constructor to this class. Now, how do we add a constructor? Well, constructors, we'll learn later in the year, are always public. They always have the same name as the class. And then in this right here, which we call its parameter list, okay, this is called its parameter list, you store all of the attribute types that you want. The order matters, and you have to name the attributes, okay? And then you put commas in between them. All right, so let's create our own attribute list here. Parameter list, okay? These are called the formal parameters. The actual parameters are what the user is going to put in. So like when I put in Brian and Zerla, those became the actual parameters, their values. And then they got used here as a copy. So here's my constructor. I'm going to say public student. Now, I'm still going to have all of this stuff. So we're going to have string, int, first name, last name, ID. But I'm going to add 2 more. The 2 that I'm going to add are going to be the GPA and the off-campus. So right here, I'm adding a formal parameter. Basically what I'm doing is I'm changing the rule. I'm saying that when you create this student, you can tell me what their GPA is. So maybe the kid transferred in from another school. And I'm going to also say, you know, when you create this student, you get to decide if they have off-campus privileges or not. Now, the names that you see on these variables up here in the parameter list really don't matter, but you might notice I was always using a slightly different name than the attributes had. That way I can keep track of who's who, okay? If they all had the same name, it would be difficult for me to tell which one's which. There's a way to do it, but we're not going to learn about it till like the end of Unit 5, so it's still pretty far away. Okay, so now what I'm going to do is I'm going to say, all right, I'm keeping in mind that Java initializes from right to left, and I'm going to take the GPA. So in a minute, we're going to put an actual parameter in there. So on the user side, the main, whoever uses this constructor will put a number there. Maybe they'll put 3.23. That number would then be used, actually a copy of it would be used to initialize this particular student's GPA. And the user of this class will also have to type in true or false for their off-campus privileges. Okay. And we will decide then to take that copy and put it in here, and that's going to become their value here. Okay, so now what I'm saying is there's another rule to create a student. You can now create a student by specifying their first name, last name, ID number, GPA, and whether or not, true or false, they have off-campus privileges. What that means is that over here, what we sometimes refer to as like the user side, somebody could now create a student. They could name it Stu4 or some other name, say that it's a new student. And as they create this student, now they can put all kinds of information in here. So if you could use your name again, or you could put in a different name, okay? But if I say Brian and Zerla, that now becomes the first and last name of this student, okay? Here's my ID number. Oh, sorry, that can't be a string, it has to be an int, okay? Now I put in their double GPA, so maybe I got a 1.23. And then I'm going to say true, I have off-campus privileges, or you could put false. It doesn't really matter, but those are only two things you could put there. All of those are separated by commas. And remember, these are called your actual parameters. So on the user side, they're putting in these actual values. Those values then get used, okay, to initialize the formal parameters, copies of them, and those become the attribute values for this particular student reference. So for example, let me just change the name here real quick. I'm going to put Benjamin. That's my son's name. And so if we came down here now and we tried the Stu3 print name, okay, but this time I'm going to say print the name of Stu4, that should retrieve the names saved with Stu4, okay, which is Benjamin Zerla. And if I added more methods to the student class, I could retrieve other things like the ID number, the GPA, the off-campus privileges, all those types of things, okay? But that variable, Stu4, holds all the attributes associated with that student. It also holds on to all of the actions that students can perform. We're going to learn more about that later. But for right now, we're focusing mainly on these attributes, and that variable, that object, okay, named Stu4, sometimes we say that that's an instance of this class. We created an instance of a student, holds on to all of those values. Over here, these are sometimes called instance fields or instance variables. Every instance of student has a value for all of those variables, okay? So Stu4 was an instance of the student class, and it held on to all of the instance variable values associated with that particular student.